Very High Bitrate Digital Subscriber Line 2 is an access technology that exploits the existing infrastructure of copper wires that were originally deployed for traditional telephone service as a way of delivering very high-speed internet access. The main high-speed link terminates at a hub near the customer's location. The existing copper wire infrastructure is then used to carry the high-speed connection for the short remaining distance to the customers. It can be deployed from central offices, from fiber optic connected cabinets located near the customer premises, or within buildings. It has been defined in standard ITU-TG 993.2 finalized in 2005. Description: VDSL2 is an enhancement to Very High Bitrate Digital Subscriber Line, recommendation G993.1, and is the newest and most advanced currently deployed standard of digital subscriber line broadband wireline communications. Designed to support the wide deployment of triple-play services such as voice, video, data, high-definition television and interactive gaming, VDSL2 is intended to enable operators and carriers to gradually, flexibly, and cost-efficiently upgrade existing XDSL infrastructure. The protocol is standardized in the International Telecommunication Union telecommunications sector as recommendation G993.2. It has been announced as finalized on May 27, 2005, and first published on February 17, 2006. Several corrections and amendments have been published in 2007 through 2011. VDSL2 permits the transmission of asymmetric and symmetric aggregate data rates up to 200 Mbps downstream and upstream on twisted pairs using a bandwidth up to 30 MHz. It deteriorates quickly from a theoretical maximum of 250 Mbps at source to 100 Mbps at 0.5 km and 50 Mbps at 1 km, but degrades at a much slower rate from there, and outperforms VDSL. Starting from 1.6 km, its performance is equal to ADSL2+. ADSL-like long-reach performance is one of the key advantages of VDSL2. LR-VDSL2-enabled systems are capable of supporting speeds of around 1 Euro/4 Mbps over distances of 4 Euro/5 km, gradually increasing the bit rate up to symmetric 100 Mbps as loop length shortens. This means that VDSL2-based systems, unlike VDSL systems, are not limited to short local loops or MTU-MDUs only, but can also be used for medium-range applications. Bonding may be used to combine multiple wire pairs to increase available capacity, or extend the copper network's reach. Profiles: the standard defines a wide range of profiles that can be used in different VDSL deployment architectures. In the central office, in the cabinet or in the building, for example. Vectoring: vectoring is a transmission method that employs the coordination of line signals for reduction of crosstalk levels and improvement of performance. It is based on the concept of noise cancellation, much like noise-cancelling headphones. The ITU-TG 993.5 standard, self-FEXT cancellation for use with VDSL2 transceivers, also known as G-vector, describes vectoring for VDSL2. The scope of recommendation ITU-TG 993.5 is specifically limited to the self-FEXT cancellation in the downstream and upstream directions. The far-end crosstalk generated by a group of near-end transceivers and interfering with the far-end transceivers of that same group is cancelled. This cancellation takes place between VDSL2 transceivers, not necessarily of the same profile. Although technically feasible at the moment, vectoring is incompatible with local loop unbundling, but future standard amendments could bring a solution. Deployment: Europe, Asia, North America, Central America and the Caribbean, South America, Africa, Oceania. See also, DOCSIS, Fiber to the X, Internet access, list of device bit rates, passive optical network, very high bitrate digital subscriber line, references. External links: DSL at DMOZ, Interoperability Laboratory, Services Testing DSL.